Lesson 510 is on relating customary and metric units. We're going to look at these two systems of measurement and we're going to see how they relate to each other. So if you look on page 317, Gianna and her friends are in a relay race. They have a pail that holds 1 liter of water. They need to fill the 1 liter pail, run 50 yards, dump the water into a large bucket until it overflows. Gianna says as long as the boys do not spill any of the water, they will need 7 trips with the 1 liter pail before the large bucket overflows. So which conversion factor could you use to determine whether Gianna is correct, and explain? Alright, so if you'll notice from the picture, they already told us that it's a 1 liter bucket that we're working with here. The big bucket they didn't tell you, but it's in the picture. So from the picture you can see we're going to be filling up a 2-gallon bucket. So looking at the chart there, we need to find a conversion factor that is going to help us out with this problem. So probably the easiest conversion for you to work with on this problem is going to be this first one here, because that relates us, that tells us that 1 gallon is about 3.79 liters. So if you use this conversion factor, so 1 gallon is about 3.79 liters. That's 1 gallon. And actually, we could do this a little bit different if you wanted to. We could do a proportion if you'd like. And then we're looking for 2 gallons, how many liters that is. Well, it's going to be twice as much. And if you do that, you're going to get 7.58 liters. If we're just filling this 1 liter bucket up, if we only do that 7 times, that'd be 7 liters. This obviously is more than 7, so we would have to say that this is not going to work. You'd say something about you would need to make 8 trips to fill the bucket. Okay, we wouldn't need much on the 8th trip, but it may even work better to not fill it right to the brim every time. Then maybe we can walk a little bit faster without spilling any of the water out. So that's one way of doing the problem. Another way is we can use the conversion that 1 liter is about 26 hundredths of a gallon. And then we can look at it kind of just looking at, they said 7 times filling this. So again, maybe this would be easier for you to look at as a proportion. So if 1 liter is about 26 hundredths of a gallon, and if we're making 7 trips with our liter bucket, we're going to have 7 liters. And so we multiply that by 7, that would be 1.82 gallons. It's a 2-gallon bucket, so that's not going to be quite enough. And so we know for sure then it's not quite enough. The question is, how much further would we have to go if they ask that question? So maybe we could try 8 liters. See how much 8 liters would give us. And that would be 2.08 gallons. So there again is confirmation that we would have to make 8 trips in order to fill the bucket. So example 1, Tyrell is using a kit to build a robot. The directions use metric units and describe the robot's height as 2 meters tall. About how many inches is 2 meters? Round to the nearest tenth. So you can see the descriptions here. There's a couple different ways we can do this problem. So one way we could look at this. Right here it tells us 1 meter is about 39.37 inches. So if it's 2 meters, it would just be twice that amount. So they kind of did almost like a proportion here. We just double both of those, is about 78.74 inches. It says round to the nearest tenth, so that's why they rounded that off to 78 and 7/10 inches. Another way we could do this is converting the meters to inches. So you could say, well, we have meters, so we can just put that over 1, and we can actually multiply by our conversion factor. This is called a conversion factor, something we multiply by where the two things are equivalent to each other. So 39.37 inches is equivalent to 1 meter. So if we multiply by that, all we're doing is changing the units, and we're getting an equivalent measurement. So you can see what they did there. Basically what happens when they do that is the meters cancel each other out, because one's in the numerator and one's in the denominator. Those units cancel, and now we have inches, and it's the same idea. Those are very similar ideas to each other. For you, maybe the first way, doing more of a proportion method might be easier for you, but either method you want to use would be fine. So if we look at the try it, Jacob is building a robot named T3X that is 75 inches tall. To the nearest tenth, how many centimeters tall is T3X? All right, so what we need to do is look for a conversion factor. If you look at the top of the page there, there's a conversion factor with inches and centimeters. So it says 1 inch is 2.54 centimeters. You'll notice these are not very nice conversions because it's kind of like two separate things. Like if I came up with a unit of measurement and you came up with the unit of measurement and then we compared them to each other, it's not likely that they're going to be a nice conversion. Like yours happens to be exactly twice as big of measurements as mine, or 5 times smaller or something like that. That's why we get 2.54. Not really the best thing to work with. So you can do the conversion factor, what the book's showing you, or we've done a little bit more stuff probably with proportions. If you want to do that, you can. So the deal is, that's our conversion, and we have 75 inches. Put the same units across from each other, and then we can look for a pattern. So pattern at this point, either we could go up and down or across. Make sure you multiply, make sure you're going towards the variable. So one option, if we go from 1 to 75, that'd be multiplying by 75. Or otherwise you can go up and down. That would be multiplying by 2.54, going towards the variable. And so we're just going to multiply this out. And it says nearest tenth, so we'll round it off if we have to. So if you multiply that out, it would be about 190 5/10 centimeters. That's to the nearest tenth. And again, we could do almost the same idea over here if you wanted to. This is just the conversion factor. And so if you multiply, you can see we're multiplying the same exact thing. So we get the same answer. Technically, they should have a little squiggly lines here because that's approximately, it's not. Actually, that comes out evenly, so cancel that. They were okay with how they had that listed. Example 2, Jenna's Alaskan Husky weighs 21 pounds. What is her Husky's approximate weight in kilograms? Round to the nearest tenth. So this is pounds. We're going to kilograms. So you can see the conversion for that would be this middle one here. So the book's showing you dimensional analysis. I'm going to show you proportion. We know it's 21 pounds. So actually, this is the part we're trying to find, is the kilograms. So you might look at that and you might say, well, that doesn't look very nice, especially if we didn't have a calculator, right? Trying to go from 2.2 to 21. That would be a little bit of a work trying to figure out a pattern with that. We do have a 1 here, though. So try to involve the 1 with your pattern. Make sure you go towards the variable, though, and think about how would we get from 2.20 to 1, multiplying or dividing by something. So that would be dividing by 2.20. You divide something by itself, you get 1. So 21, this is what we're doing basically. 21 divided by 2 20 hundredths. And they're rounding this off to the nearest tenth. We should get the same thing as them. Should be about 9 5/10 kilograms.